Narwhals is probably the most downloaded project. Nobody intentionally downloads. That's how I sometimes like to describe it. We're closing in on 20 million downloads a month or something like that, but of these, I think probably less than 0.1%, even much less than that, of people installing Narwhals.
In this episode of Inspiring Computing, Marco discusses the unexpected success of Narwhals, a highly downloaded and extremely lightweight and extensible compatibility layer between data frame libraries, such as pandas and polars. We dive into Marco's inspiring journey from a mathematics background to becoming a key contributor in the open source community. Marco shares his initial struggles, motivations, and the eventual widespread adoption of Narwhals. The conversation goes into the technical underpinnings of his project, from the importance of typing to robust testing techniques. He highlights collaborations, testing practices, and the challenges of maintaining backwards compatibility. This episode is both a technical deep dive and an inspiring story of persevering through challenges and negativity to make a substantial impact in the open source ecosystem. The Inspiring Computing podcast is where computing meets the real world. This podcast aims to trigger your curiosity by talking to proficient and advanced users of MATLAB, Python, and Julia, who use these tools to deepen their understanding of the world, simulate, explore trade-offs, and gain insights that help companies add more value. In addition to this, we will also be talking to product marketing, toolbox authors, package developers, and library maintainers to see what drives the development and what issues they're solving for others to benefit from. Welcome, Marco, to Inspiring Computing.
Thank you for having me.
So you and I have met at a PyData conference in the Eindhoven region where Richie, the authors of Polars, gave a keynote talk. And ever since then, I've been following your trajectory quite closely. Above and beyond you working at Quansight, which is a very cool company, you in the meantime have created this awesome thing called Narwhals, which somehow conquered the world. Can you maybe tell us a little bit about who is Marco and what's your superhero origin story? How did this half Italian person living in Wales, studying in Oxford, come and create one of the fastest adopted packages in the planet?
I should get you to write my CV for me. You're making me sound very good. My background's in mathematics. I had quite an interest in that, so that's what I studied at university, but then figured I probably wasn't good enough to become a mathematical researcher and make a living out of that. In academia, you really need to be in the top 0.1% to make it, and I didn't want to risk it. I didn't think I was going to be able to prove that I was part of that select few. So I figured I should probably learn to code. And initially from Coursera, took some courses on data science and Python. Managed to land my first job as a data scientist after refusing a lot of jobs to be management consultant and those kinds of things. Like you mentioned Oxford earlier, then straight out of uni, you're going to get a lot of offers to do these kind of consultant jobs, which can pay pretty well. And that would probably have been the local maximum, but it wasn't the kind of job I was interested in having longer term. So I decided I'd prefer to learn to program, learn data science. I really enjoyed working as a data scientist, but I caught the open source bug while I was doing that. One day, as part of a job I had at Samsung, I just encountered some issues with pandas when upgrading a version. Reported the issue to pandas and they encouraged me to submit a pull request. I was new to open source, so I didn't know how to do that, but I learned the contributing guide, learned a bit about how to do that, and got an adrenaline rush when they finally merged and approved my little contribution, which was just about improving an error message.
Was that your first ever open source pull request?
My first ever open source pull request in general was actually to scikit-learn, but that wasn't... Let's say in pandas it was the first code pull request. In scikit-learn I was just clarifying something in the doc string. There's the... What is the standard scalar, where degrees of freedom aren't configurable, and I just left a little note in the documentation noting what the default was. It was really minor, but I still showed off about it for weeks when they approved that. Pandas was the first time that I was actually dealing with code and writing tests and trying to follow definitions to see where things went. I thought that readcsv would just be somewhere I would find the definition of a function called readcsv, but it went a lot deeper than that. Fortunately, that part that I had to modify was still in Python, because a lot of pandas is Python or C, which at the time I
Yeah.
could not have had any chance of contributing to, but this part was all Python. I was able to improve the error message, and that was my nice first contribution. I got a bit addicted to the process, especially then during the COVID lockdowns. And about a year later, I think I was invited to join the core team in Pandas. But it stayed as a hobby, like volunteer thing for quite a while, until a startup I was working at, they had a return to the office mandate at the time. Quantsite put out a job posting looking for a Pandas maintainer. So I figured, yeah, okay, let's give this a go, see what this is like. I was apprehensive about changing direction from data science. I was in a senior data science position at the time. I guessed that if I'd continued, I could eventually have gone into some lead position. So this would have meant for me just changing path, like going into software engineering, leaving behind the whatever forecasting and modeling skills I'd developed. But I figured it was a chance to get paid to do open source. If I spend 2 years doing this and then I have to go back to data science, then it'll still have been worth it. Like, it's worth to take a chance to do this. And yeah, definitely glad I took the chance, because since then it's allowed me to go much deeper into open source. And it's allowed me to tackle much more difficult problems, which I just would not have had the chance to do as a volunteer. Whereas if you've got funded company time to spend like months working on a difficult issue, then all of a sudden fundamental issues in open source projects, actually, it becomes possible to solve them. So the impact that Quantsite is having by sponsoring people to work on open source, I think, is quite large. But you've interviewed quite a few people from Quantsite on your podcast. I encourage listeners to listen to the episodes with Athan and Ralph.
Very good. But so then let me see if I got this straight. So you started open source relatively late, I guess, in your career, but you stepped up during COVID, and then you joined Quantsite. But then you created this thing called Narwhals, right? First of all, what is Narwhals and where did it come from?
Sure. Narwhals I picture it as a lightweight compatibility layer between data frame libraries. The idea is that it lets you write tools which can be data frame agnostic. It's a tool for tool builders. So if you want to make some package that other people are going to use, you don't know what data frame library these people are going to be passing in. Some might pass in a Pandas data frame, some might pass in a Bowler's data frame. You might even want to support lazy libraries. You might want to support GPU-bound libraries like QDF. And how do you do this? If you only need to support, say, Pandas and QDF, then their APIs are very similar. So you can probably just write your code once. Be careful that you're not using some of Pandas' most exotic features, and it'll probably work for both. The moment you start doing slightly more complicated things, it becomes trickier. And the moment you want to support libraries with completely different APIs, such as Solus, PySpark, and PyArrow, then all of a sudden, trying to duplicate your logic for each new library you want to support becomes infeasibly difficult. If you then also want to support different versions of these libraries, say you want to support Pandas starting from version 1, then you're going to have even more if-then statements to deal with API differences between, say, Pandas 1 and Pandas 2, and then Pandas 3 is probably going to come out at some point in 2025. It quickly gets infeasibly complicated and becomes infeasibly difficult to test. With Narwhals, you just express your logic once, and then depending on the input that the user passes in, Narwhals translates to the appropriate data frame library, and it deals with library incompatibilities for you. So that's the idea behind what is Narwhals. The other thing you asked about was how did Narwhals get started?
Yeah, so how did you come up with this? The way you described it just now seems like everybody in the planet for every open source project must have something similar like this. It feels such a logical thing, but it took a while for Narwhals to appear in the world. How did you come up with this idea?
It seems like a logical thing now, which is interesting to say, because like when I started it, certainly a lot of people didn't get it. I encountered a fair bit of negativity around it, like people saying that nobody would trust my little project anyway, and that people could just use some other related tools, and that it was just never going to be feature complete enough to be useful. I just bring this up to say, if any listener is starting a project, sometimes you've just got to power through the negativity. You've just got to believe in something and be prepared to throw it away. I don't know, give it 6 months, a year or something. maybe the haters were correct, but you're not going to know until you put some effort into trying to make it work and be prepared to throw it away if it doesn't work. And if it works, then you get to prove the haters wrong. You win it.
I like that. Prove the haters wrong is a motivation to keep going. I think it's
wow.
underestimated of how hard it can be when you get your first negative responses in maintaining an open source project. And you're like, oh, I put all this work in and there's somebody on the planet who's very vocal and doesn't like my work. Where probably the people who love it just are not as vocal, right? That's a valuable lesson learned.
Yeah, but it's not just negativity. I think none of us really mind too much negativity from random strangers on the internet. If I'd posted, I didn't do this, but if I'd posted about Narwhals on Reddit, say, and some anonymous user posted something negative about it, I don't think this would have affected me. But when I got some very famous people from other projects, maintainers of other projects, just offering their unsolicited opinion that Narwhals was useless and that I could just have used some other projects instead, it hurt me a bit more. And trying to prove them wrong really became a bit of a revenge project of mine. And as it turns out, revenge is a pretty good motivating force. There were certainly parts when I was getting started when I realized that if I wanted to get users, I had to have doc strings for every function, or I had to have good user guides and tutorials. These things, for a library author, for a maintainer, they're certainly a lot less quote-unquote fun compared to solving difficult problems and getting broadcasting to work correctly and the kinds of technical problems that probably get you excited about a project at first. But I just had in the back of my mind that I wanted to prove some people wrong, and that's what kept me going.
So you said a relatively small project. So maybe to put some context around this. So how big is Narwhals now? So how many people are actually downloading this per month?
Narwhals is probably the most downloaded project. Nobody intentionally downloads. That's how I sometimes like to describe it. I think last month we're closing in on 20 million a month or something like that. But of these, I think probably less than 0.1%, even much less than that, are people installing Narwhals. It's mostly people who are using tools built on top of Narwhals. I said earlier that Narwhals is a tool for tool builders. And I think this is what a lot of people just didn't get at the beginning. There's that XKCD comic about competing standards, where somebody is looking at the ecosystem and saying, okay, there's 14 competing APIs. This is a mess. Let's make one new standard which is going to address everybody's needs, and it's going to bring everything together. And then soon the situation becomes there are 15 competing APIs. I think a lot of people, they thought that was what I was trying to do with Narwhals. I was trying to build the last API you'll ever need to learn, like the API to kill all APIs to solve everyone's problems. And it wasn't anything like that. It was really just a tool for tool builders. We're just trying to make it easier for maintainers to support different tools. And it really came from the observation that data science tools typically aren't doing crazy advanced things with data frames. Like they care about data types, they care about column selection, filtering, adding new columns, iterating over groups, converting to NumPy. Once you go through the code bases of a few data science tools and what they're doing with data frames, you come up with a list of things that they need, and it's not that extensive. And that's really how, practically speaking, Narwhals got started, just very pragmatically looking at tools. The first big tool to use Narwhals was Altair. So I was just looking through the code base, seeing what would we need to add to Narwhals in order to be able to Narwhalify Altair. Then we did the same with Plotly and some other libraries. I tried Narwhalifying Profit. I don't have a huge interest in submitting a pull request because it would be quite a lot of work, and I don't recommend that anybody uses Profit. But it taught me a lot about what features we were missing in Narwhals, and it helped to find some slight issues. So I really recommend that people dog food their own tools to themselves. If you want to build a good tool, you need to try using it. Then you'll realize what the user experience is like.
But there's a couple of things I'd like to double click on there. So you mentioned that, okay, so relatively small project, closing on 20 million downloads. So this is no longer really small. This is really big, widely used. But if I understand correctly, it's because there are large ecosystems that adopt it. So you mentioned Altair started off and you've slowly but surely progressed. So I think most people, or at least when I speak about Narwhals, they think, oh, it's an API for pandas and polars, but you're much broader than that. So can you maybe tell me a little bit of, starting from Altair, which were the ecosystems that adopted? Or
Yeah, sure. It started off as just a project that I posted on GitHub, and I presented it as part of a talk I gave at PyCon Lithuania last year. It started about a year ago, by the way. I think the first commit message was 14th of February 2024 at about midday. And
Valentine's Day.
Yeah, it was Valentine's Day.
Yeah.
I guess my partner and I hadn't gone out for lunch that day. We probably celebrated in the evening. But evidently we weren't celebrating anything at 12 or 11 or what time it was, because that's when I made the first commit to Narwhals, which in typical Marco style was WIP. Yeah, do as I say, not as I do. WIP is a very bad commit message, but that was the first commit in Narwhals, and I can't change it. How did it happen? Yeah, I just published it on GitHub. I spoke to some people about it, sent it to a newsletter, PyCoders Weekly. They were kind enough to publish it, so it started getting some stars on GitHub. I wasn't really prepared to spam it to everyone quite at this stage. I didn't really want to present it in public too much. I was expecting that it would just be something that I would get ready, see if in a year's time or so we could build up enough features to be useful, attract some contributors, and maybe then we could find some minor use cases. I was certainly not expecting that in less than a year's time it would be adopted by Altair, Plotly, and others. In fact, I was so not expecting Altair to use it that when one of the Altair maintainers on GitHub tagged me saying, "Has anyone seen this Narwhals project? Maybe we should use it in Altair," I was so convinced that the other maintainers would not actually want to use it that I actually suggested to them, maybe we can just start by making a separate code path for polars, and then later we can generalize using Narwhals if there's interest. But I really did not think that anyone would trust this little project that I'd started. And I was very, my priority at the time, and it still is my priority, I really want Polars adoption to spread in the data science ecosystem. I really want the data science ecosystem to become less locked into pandas. No disrespect to pandas. I want for pandas to still be supported and for pandas use cases to keep working, but I don't want them to be the only data frame library supported. Right. So there in the issue, one of the maintainers was suggesting Narwhals. I suggested maybe we can just start with polars. Then the other maintainer said, "Oh, but this looks like the kind of abstraction layer we need. Can we try using Narwhals directly?" And at that point, I made the decision to drop everything else I was doing outside of work. And I was just going to go all in on trying to get Narwhals into Altair. I figured, okay, if we can do this, it's going to be significant enough to really potentially launch the project. And we went overboard with it, just testing everything so carefully. We added Altair to our downstream tests, so any pull request we make to Narwhals, it also runs the Altair tests to check that we're not accidentally breaking anything for them. And now that's something that we do for virtually every library that supports Narwhals. As long as their test suite isn't infeasibly long, we just add them to our downstream tests. It gives us an extra layer of confidence, and sometimes it helps find things that we're not testing against, because you cannot come up with all the possible tests yourself. You don't know how people are going to use your library, so including downstream tests is really a lifesaver. And from there, it just spread. At that point, there was a post about it on the Polars blog. Once people started seeing that it was getting downloaded, the word spread. The engineering manager from Plotly reached out and said that they might want to get an intern to work on it. They said that maybe in a few months an intern from Plotly would start working on it, but there was another contributor to Narwhals, Francesco, who was just so excited about trying to Narwhalify Plotly that he went ahead and did it himself. So that's happened. The Plotly team were really great to work with, and they made a release with Narwhals earlier this year. Then Marimo started using it by themselves upon Vincent Warmadam's recommendation. So it's really been fairly organic growth since then. We've never, paid data science influencers to hype it up or anything like that, which I know some projects do.
So tell me a little bit more on which libraries you're trying to support inside Narwhals.
All of our major use cases so far have been for eager execution. If you're plotting a library, for example, if you're visualizing it, if you're making a table, then typically you require concrete data. in theory, I guess you could make a lazy plot. I'm not aware of any lazy libraries existing. So far, the focus has mainly been on eager execution. Since about October, November, so after we got the Plotly integration done, we've really started focusing on lazy execution inside Narwhals. Up until then, we did have some support for lazy libraries, but since about November or December, we've really been doubling down on that. We now have, I think, fairly decent support for PySpark and SQL Frame. SQL Frame is not a very well-known library, but it's really amazing. It basically turns PySpark into a universal data frame API. So then you can compile to SQL, you can execute with DuckDB, Redshift, a bunch of other backends. If people can pass in a SQL frame, which is built upon one of those, then they can dispatch to these backends just using like the PySpark API from SQL frame. Or if they want to do it via Narwhals, they can do it with the Polars API. So we've really been stepping support up for those, and that made us realize that we'd made some design decisions initially that were not quite correct. We'd started off making things a bit too Polars and Pandas centric, and these SQL frontends, they deal with things differently. They've got some extra restrictions which Pandas and Polars don't have. They typically don't assume that the row order is defined. So in a Polars lazy frame, even though it's lazy and the row order doesn't exist until it's materialized, if you do a select statement, the output is going to be in the same order. But in SQL, that's not the case. DuckDB does preserve order in some cases, but not always. In particular, if you do window functions, then the order is not preserved. And that's when we realized we needed to really make a split in Narwhals. We really needed to differentiate between eager APIs and lazy APIs. For eager APIs, we pretty much have no restrictions. Your data is assumed to already be in memory. Row order is defined. You can do whatever you want. As long as the API lets you express it, it should be well defined. In the lazy API, though, we are much closer to SQL. So that means you can't, for example, select one column and then select another column in which you change the order. If you do that, then that's not relational. You're ending up with tuples which were not part of your original output. It's not the kind of thing that SQL would let you do. We also, unfortunately, have to introduce some restrictions, which to me seem a bit arbitrary, such as that you can't have two window functions within the same over statement. Like in SQL, you can't do, for example, shift and then mean and then over. You need to first make a common table expression. And we're like, okay, if this is supposed to let you write data frame agnostic code, then we probably need to introduce these restrictions so that if you're able to express something using the lazy Narwhals API, then you should be confident enough that it's going to work, not just for Polars lazy, but also for DuckDB and also for PySpark. It's been a lot of work to rewrite everything and keep everything backwards compatible, keep everything working in the eager API.
So maybe just to double click on something there, you said a couple of things. You live and breathe this, right? So you naturally know lazy versus eager. So can you first of all clarify what that means? And then maybe can you double click on some of the weird decisions that you started with that now, or that was a bad call and now you've had to change it? And what are some of the things that you're thinking, in the future, I have to even be more aware? Because some of these things don't come naturally to someone who has been using pandas every day of their life. They just don't think about lazy versus eager. And then you go to the Polars world and it's, there's this concept lazy. Oh, cool. But actually, I don't understand what's going underneath the hood. Can you enlighten us, maybe the data scientist who doesn't care too much about that, why this is so important?
Definitely. It's really important when you're dealing with largish data. The main difference is that when you're working in the lazy context, then execution is deferred. In the lazy context, you're just building up a set of instructions, whereas in the eager context, you're doing one step at a time. Maybe the difference is if between trying to cook something, like reading one step at a time from a recipe book, can work if it's a relatively simple dish that you're trying to create. But if you want to do a complex dish, then you're probably going to have to first read the entire recipe, and then you're going to have to make some decisions about which steps you can do at the same time, and the timing things, they come together. I think the lazy versus eager distinction is somewhat similar to that. In the lazy case, you're building up some recipe for how to create a final data frame. Once you decide, now it's time to produce the results, then the library can decide how to combine things, how to reorder your instructions, whether some instructions just don't even need to be done. If you're doing all of this lazily, then query engine can decide that some of these means just didn't need to be computed in the first place, and this can save you a lot of time. It can also save you a lot of memory, which is why with Polar's Lazy and with DuckDB, you can process really large datasets just on your laptop.
Right. So that's something that I guess people somewhat take for granted, right? So think of you cooking a meal at home versus a professional chef in a Michelin star where they're cranking out dishes left and center. There's a highly optimized workflow with all the chefs coordinating and doing things that the end user just wants a nice meal, but it's a significant difference in being able to crank these things out. So I think that is very cool. But I think then for Narwhals project, does that mean that you have to support everything? Is the goal to be able to support every single API and all these frameworks? Or do you consciously say, no, it only makes sense to support a subset of things which are possible? And how do you decide what makes it and what does not make it? Because as you expand into different ecosystems, you probably have more restrictions. Can you tell me a little bit more about some of these lessons learned in the newer ones, perhaps?
And this has been really on the top of my mind because I don't want this to become the everything project. I want the major APIs to be supported within Narwhals. Yeah, the Pandas API, of course. There's the Polars API, PySpark. I think PySpark, DuckDB, SQL Frame, these are all just like SQL front ends. These are all very similar. And then there's PyArrow. If there's any other library that comes along, I'm not aware of any other open source library that's as significant as these others at the moment. So if there was any other library that people would want support for inside of Narwhals, then at the moment, I think that they should either fund the development of it, or they can write an extension. Now, the extension mechanism in Narwhals is still a bit experimental, but the idea is that if you make a data frame wrapper and you define certain magic attributes, such as __ narwhals data frame __, and then there's similarly one for lazy frame and one for series, if you have the concept of series in your library, then you can have your library work with Narwhals without having to ask us to do anything. And like this, if somebody has a closed source project that they just cannot open source, they cannot have anything about it in the wild, they do have the mechanism to extend Narwhals and be compatible with any library written on top of Narwhals. So if you've got your closed source data frame library and you really want to be able to pass it to Plotly, if you follow the instructions for extending Narwhals, then someone should be able to pass your data frame library directly to Plotly, and it should all work without neither us in Narwhals and neither Plotly having any knowledge about your data frame library. This is an example of what standards enable. Standards really drive and enable freedom. I will say this extension mechanism is currently a bit experimental. I'm not aware of anyone having actually done it yet, but I really want to formalize it, and I really want to see if we can publish a paper, say, in the Journal of Open Source Software to make it a bit more formal and stable, and then really try to encourage people to make use of this. So as for the bar of what's in Narwhals and what's out of it, at the moment the bar is big, significant open source projects. Yeah, they can go into Narwhals. Anything outside of that we're not sure of, they can write their own extension.
When you say maintaining, you said a little bit earlier, a little bit about the testing, right? I have to believe that as you started looking at APIs and other open source projects, I mean, we're all humans, you probably uncovered stuff that you were like, oh, by the way, you were not aware that you've got your own few bugs because you're comparing across multiple ecosystems. But then you also mentioned the downstream testing. So can you maybe tell me a little bit about some cool things that you discovered on other people's projects that because of what you were doing, and or how do you actually test this on? I'm really curious of how do you maintain Narwhals, because everyone has to say if using pandas 1.5 or 1.2, or then if using pandas 2.0, and then the same thing happens for polars. How do you test this whole thing? Because now you're making an ugly to maintain thing for the whole world.
We are doing some ugly to maintain things for the whole world, but also this is the only thing that our library does. So we just decide, okay, yeah, this is our problem to solve, and this is what we're going to focus on. Whereas, say, a data visualization library, they want to focus on solving data visualization problems. They don't want to worry about whether they should pass the copy keyword argument in which version of pandas.
Right.
They don't want to worry about whether something creates a copy or something resets the index or something happens positionally or by label like this, or all these things that they don't really want to worry about. Whereas for us, this is the only problem we're trying to solve. So to us, it's much more manageable. How do we test it? Typically, our tests just parameterize over different constructors. So we parameterize, like we start with some dictionary of data, and then we pass it to Narwhals, perform some transformation, and then compare it against some expected output. And we just parameterize over pandas, different flavors of pandas. So there's PyArrow-backed pandas, NumPy nullable-backed pandas, classic NumPy pandas, PyArrow tables, Polars eager, Polars lazy, DuckDB, PySpark, SQL Frame, and Modin as well. And then Modin by PyArrow, QDF. It takes some effort, but it's been really wonderful. Was pretty lucky that there was a colleague at Quantsite who was a maintainer of Hypothesis, so he showed me some cool PyTest tricks. He showed me how to use, I think they're called meta fixtures. I didn't even know that this existed, but that helped. That really did wonders for making all of this maintainable and achievable. And in terms of bugs, yeah, we've been reporting bugs left, right, and center in virtually, I think, every single library that we support. We've found bugs, some more than others. I will say to anyone listening, if you ever see a library that promises to speed up pandas by just changing one line of code, then you better have some pretty solid tests. Like, I do not trust them after having seen how many bugs we've uncovered. Then generally, a lot of them have proved to be incredibly robust.
Tell me a little bit more about the testing. So how does it, a person who studies maths, who hasn't got a formal education on computer science, in a short period of a couple of years, iterate to building one of the more complicated downstream testing frameworks on GitHub to find errors in all mainstream data frame libraries? How did you come to that place? Because my experience is domain experts don't typically care about this. Testing becomes an afterthought. What triggered you to make it such a front-end predominant thing? How did you think about spending so much time on it? Because I think in the Narwhals project, I think part of the biggest added value is you actually thought about this testing and probably the backwards compatibility around all of this, and you put more effort there than maybe people perceive.
Definitely put more effort than some people might perceive on the backwards compatibility. So maybe let's come back to that in a second. As to how we became so obsessed with it, I really need to put in a good word for collaborating with other people. So I got some phenomenally good contributors to Narwhals. I definitely could not have done this by myself. And I mentioned earlier my ex-colleague from Quantsite, who was a maintainer of Hypothesis, who just knew every PyTest trick in the book. And yeah, you're not an island. You cannot do anything by yourself, completely alone. I think we're at the stage where any problem that's interesting enough cannot be solved just by one person working alone. You just need to collaborate with others.
But collaborating is one thing, but accepting the advice, right? So you can go to any project and say, yeah, you should do better testing. And people tend to say, yeah, that's on my to-do list, but I got these other features to think about. But I can only do the other features if and only if I listen to this other person who tells me testing is really important and this is how you set it up. And then once you set it up, that actually saved you time downstream at an exponential level, right?
Oh, yeah, definitely. I think sometimes I could have listened to people a bit better. Sometimes I've been a bit overconfident with my own opinions.
So in my mind, the advanced testing you have is probably also catering for quite a lot of backwards compatibility. Tell me a little bit more about your thoughts and how you got to the stage of where you are today.
This is something I really kind of agonized over for quite a while. which is what do we do about backwards incompatible changes? The issue is that if you're an end user, if you've got some analysis that you're doing using pandas or something, and pandas makes some slight change to their API, it's not that bad for you to just update your code. But if you're building a tool on top of pandas, then all of a sudden you probably don't want to bump your minimum pandas version too much. You probably still want to support people using older versions of pandas. And at that point, you need to have some condition for if pandas is greater than this version, do this. If it's less than this version, do this other thing. And if we were going to follow the Polars API, then what do we do if Polars changes its API? Do we want to keep Narwhals stuck in some old Polars API, diverge from the Polars API? Do we want to deprecate and go towards the new one? And none of these solutions are great, really. I didn't like any of them. So what did we do? We ended up doing something really inspired by Rust. Rust has this concept of editions, whereby when you start a Rust project, you can specify which edition of the language you want to use in your cargo.toml file, which for Pythonistas, that's the Rust equivalent of your pyproject.toml. And these editions, they might contain incompatible changes. If you specify that you've got the 2015 edition of Rust, and you write your project, then in theory, this project is going to keep working and it's going to keep compiling on any future version of Rust. You might at some point want to make use of some newer feature or some backwards incompatible change, but then it's up to you to say that you want the 2018 edition of Rust. I heard from a talk from the Rust maintainers that they thought this was going to be absolutely crazy and crazy difficult to maintain, but in the end it just really wasn't that bad. And so I figured, okay, I'd like to try something similar. So in Narwhals, you can either import Narwhals directly, do import Narwhals as NW, because it's the law in data science that everything be imported as a two-letter acronym. Or you can do import narwhals.stable.v1 as NW. And if you do that, then the promise we make is that your code should keep working even in future versions of Narwhals. We might make some breaking changes in the main Narwhals namespace, but narwhals.stable.v1, we're going to keep that as it is. And that's really been a lifesaver. Altair made their first release using Narwhals. They were doing some comparisons between data types, which we then ended up changing. And I really wanted to make the change because the way we originally allowed data types to be compared just wasn't really correct. Once you allowed for data types to have metadata attached to them, it just wasn't. Well, we don't need to go into the details, but basically we'd made a design error. But we really did not want to break Altair's users' code, and we didn't want to force Altair users to have to upgrade their Narwhals version. Most Altair users should not know about Narwhals. This is fairly important to me. If an Altair user has to know about Narwhals, then it means that it's probably because of a bug that Narwhals has introduced. It should just be some name that they see in their requirements.txt file or by project or whatever. It should not be something that they're interacting with directly. What we did was, in Altair, they wrote their code using the narwhals.stable.v1 API. So when we made these breaking changes to the data types in Narwhals, we kept them exactly the same in narwhals.stable.v1, but we introduced the breaking changes in Narwhals, in the main Narwhals namespace. So then, when we get to narwhals.stable.v2, that's going to have the new, more correct behavior, but we're going to keep the old, technically incorrect behavior around in narwhals.stable.v1 so that people using old versions of Altair who might not necessarily be able to upgrade their Altair version, they're not going to be broken by new versions of Narwhals.
So this is a really fundamental thing, right? So I think these large projects, for example, Pandas, it's become such a mammoth thing, and also NumPy, that any change is very much considered, and lots of people are worried about it because of its reach. But the way you just described it is, this solution is independent of your reach. You can enable different groups to adopt at different paces just by introducing this kind of philosophy, which I don't think is so common in the Python ecosystem. So what you're doing is actually special, right? Are there other large Python projects that deal with it the same way with the .stable, .v1, .v2? Or are you unique by borrowing this from the Rust ecosystem?
In my head, we're the first Python project to do this. I'm almost certain that I've independently done something that somebody else had already thought of. But in my head, I just wasn't, and I'm still not aware of other projects having done something like this. I don't want to claim that we're the first, but I wasn't, when we started it, I wasn't aware of other projects having done it.
But you thought about it, right? So I think that's something special that you actually thought a lot about this, because indeed, backwards compatibility for your project, this is a big deal.
It's a huge
deal. So well done
yeah.
for coming up on this.
Oh, thanks, yeah, because people cannot just pin their Narwhals version. Imagine if Plotly pins their Narwhals version to 1.26 and Altair pins their Altair pins their Narwhals version to 1.30. Then surely there's users using both plotting libraries, and all of a sudden they can't use both of them. It's a disaster. We really need to allow, maybe they can have different minimum versions, but we really don't want anyone pinning their Narwhals version.
Yeah, so I think one of the things that I really like about Narwhals, great success project, adopted, conceptually easy to understand. It's more for tool developers, so it's not for the end users so much. But the fact that you thought about this, I almost think it's a reference for the other libraries, which are also for tool builders, to think about this backwards compatibility, because I think the ecosystem fragmentation happens too often. And then you say, can't like the UV fix this problem for me, or the Pixie solve this problem for me, but it's actually inherently not the packages themselves that have to fix it. It's the authors of these tools should create a framework where that works. And I think you only learn that maybe after the project is so successful, and then it's too much of a burden to get this right. So I'm very happy to see that you thought about it ahead of the time and brought it in early. So I think this is a really good example for many other tool developer tools out there.
Oh, thank you. Yeah, I mean, I knew for certain that I was going to make design mistakes. This was a way to future-proof things.
Wow, it is cool. So I also have, there's one other thing that I've always wondered. Maybe you've said it in other places, but I never picked up. So narwhals, why on earth narwhals? In all honesty, excuse my ignorance, I had to look up what on earth is a narwhal. And I was like, oh, I'd never seen one of these things before. So I'm Portuguese and they don't swim out of the Atlantic Ocean. I'd not seen one in the Atlantic Ocean. So what's the story behind this?
The original name for the project was Polar's API Compat. And that's still what the folder is called in my local directory. And like, when I do hacking on Narwhals, for me, it's just a CD Polar's API Compat. I've still not renamed my local folder. But then I thought, yeah, that's just too boring of a project. And I went back to her saying that at the beginning I really want to take revenge on some haters. And I thought, okay, how do we get people to use it? It needs to be engaging. It needs to be fun. People want to be entertained. That's just the reality of the world we live in. People want entertainment. And whether it's in tech talks, whether it's in packages that they use, people like it if things are somewhat entertaining and attention-grabbing. And I thought there was no chance of us doing that if the project was called Polar's API Compat. It also sounded a bit too similar to the Array API Compat, which is a project that both Athel and Ralph have talked about on previous episodes of your podcast, which I again recommend people go back and listen to if they want to hear about similar things that have been happening in the Array ecosystem. And I just thought, look, this needs to be different. It's a different project. We need a silly name. And we need an animal, because every successful data project has been named after an animal. And what's a Nordic animal? There's polar bears in the North Pole. This should be similar to the Polar's API, so we probably want an animal that lives there. And looking through the list of Nordic animals on Wikipedia, I found puffin and thought, this is the perfect name for the project. Unfortunately, it was already taken, and the author of the library was not willing to give it up.
Oh, so you actually reached out?
I reached out, yeah. This person, they published this library 10 years ago. It gets about 1 download a month. Nobody's using it, but still, they were not willing to give it up. I was a bit annoyed about that. I started looking into whether there was any action I could take about taking over abandoned projects. The response rate on the GitHub repository was just so slow. I just realized that we needed a different name. And when I went back to that list on Wikipedia, I found the Narwhal on that list. Yeah. And there was a viral song called Narwhals, about narwhals are swimming in the ocean, causing a commotion. And I loved that song. It was amazing. I thought it would be funny to have a project named after that. And as you said, most people don't know what a narwhal is, so we can educate people about this endangered species. it makes for good logo content. It's a fairly recognizable thing. I got an artist to draw as an illustration. Yeah, that's right. I paid an artist. It's not AI generated. And that's the genesis of the name.
So you're touching on something really important here, even though you say it with a big smile on your face, that names matter, right? Choosing a name of a project really does matter. And most technical folk start open source projects with a very technical issue, and then they just want to solve it, and then it becomes successful by chance or not. And then somebody says, well, maybe you looked at this with a marketing perspective and adoption rate, that it seems like that is quite strong in you by nature. So you thinking about paying someone to do a logo and choosing the name carefully, well done on you.
Just thanks. I don't know if part of it comes from just having low expectations that people will pay attention to what I'm doing. Maybe earlier when you asked about my origin story, even before becoming a mathematician, I thought I wanted to be a musician. And maybe I've just become desensitized to performing in pubs and having people just minding their own business and realizing that if you want people to pay attention to you, you need to be twice as entertaining as you think you need to be. And I guess this carried across to open source.
I think it's a good lesson to be learned, because you're unique in a way that you started on open source relatively short time ago. So this is not something that you've been doing for 20 years. So your trajectory from your first, I want to change a document or clarification, pull request is typically where people start, then to code, but then you've just leaped towards creating something else which has been massively adopted. Did you pull from the experience of how you felt? And because it was such a short period from, I wish as an end user contributing, I would have made it easier, that you pulled and learned from that? Because I think many people are scared for that full first pull request.
I'd encourage people to not be scared. It depends on the project, really. I think you can get a vibe for a project just by seeing how maintainers interact with people. And the vast majority of interactions I've had in GitHub making pull requests have been really positive. There are some projects where I think maintainers can be considered toxic. So if you want to contribute, I really recommend starting small, test the waters, see if people seem friendly and encouraging enough. And if you don't get good vibes from the project, then just don't devote your free time to doing free work for them.
So tell me, how did you set up Narwhals to embrace all these contributors? Because you said earlier on that you can't do a project by yourself, so you consciously set this up, as far as I can tell, so that you're making it easy for people to collaborate. Tell me a little bit more of some of the thoughts and decisions that you took early on that you think is the best practice.
There's a few things we did to try to make it easy. A lot of it just has to do with over-communicating. Fairly early on, I wrote a little guide called How It Works, which end users don't need to care about. It's useful if you know how something works. So that just explains the general idea behind Narwhals. When we say expression, what do we mean by that? How does an expression work under the hood? I think that's helped. I heard from some contributors that having good type hints really helped them make sense of the project. In terms of over communication, a couple of things that we do is, one, we've got a Discord server where people can just ask quick questions. We tend to prefer that things happen out in the open on GitHub so that it's easier to find, but also a lot of people really prefer to just ask quick questions on a little Discord server. It's a bit more friendly and less intimidating than asking something out in the open on GitHub, where I think a lot of people are very worried about being judged by the questions that they ask in public. Whereas, on just a little Discord server, it can feel much less scary. We've also got a bi-weekly contributor call. So every 2 weeks, we just have a call that's absolutely open to anyone. Anyone can join. And that's a good chance to talk a bit about roadmap, but also just if anyone's got any question that they want to ask or any help with any contribution that they're working on, that's the ideal moment that they can just hop onto a call with us. We can help them and answer questions. And then the other thing that I do is every 2 weeks I do a live stream. I just connect to YouTube and just live stream some development. I thought it was just going to be me talking to the wall for 2 hours, but to my pleasant surprise, people do actually seem to turn up and ask questions and watch. I know that a lot of them do actually watch because sometimes they comment that I'm like hiding my editor with a window.
What do you do on this YouTube channel? So I was not aware of your YouTube streaming. So is it just like you creating a new release or like the Python releases, or is it you solving a pull request, or what do you do in that?
This is on the QuantSight YouTube channel. It's really just whatever happens to be highest on my priority list at the time. So sometimes it's reviewing pull requests. Sometimes it's making some slight fix up to pull requests so that they're ready to be merged. Some people say that you shouldn't touch contributors' pull requests, you should tell them what to do. Personally, I'm more of the opinion that if something's almost ready, then rather than putting a contributor through like tons of reviews, you should just fix it up and merge it.
And they can learn if they want to after the fact. Yeah.
It also just reflects my own personal experience. Like if I've put the effort into a pull request and then I get really minor comments about, but can you refactor this out into a function? Then, yeah, sure, I can do it. But also, I much prefer if it just happens a lot quicker and either somebody does it for me or they just say, okay, I'm going to merge this for now so that it solves the problem. Please submit a follow-up in which you factor this out into a function. I like it if things move fast. So I've tried to keep the same kind of thing with my own contributors. And yeah, I'll generally try to keep it quite welcoming in that way.
So I'll definitely put links in the show notes to that. I very much like the idea of you streaming and opening up, because it's a scary thing to do this in front of an audience, but it's good that you do that. You mentioned the word typing. So I'm assuming that when you started this journey as a data scientist, you couldn't care less about typing, right? But now, if I understand correctly, your project thrives and needs typing and you're a strong believer in it. So tell me a little bit of what was that turning point for you as an individual to say that, okay, I'm full on board with typing and this is why it's so important. And what is its implications in the Narwhals project?
I think when I started off as a data scientist, I just did not know about type-ins. Like the Python I'd seen from the courses was completely untyped. But I think when I first came across type-ins from a colleague's code base, I was instantly on board. I just thought, oh yeah, this makes so much sense. Like, why document things by hand if you can, like, before that I was just having to put so much effort into writing in the doc strings, like what types do I expect? Whereas if you can just have it in the signature and then have some tool which automatically verifies that the types you've declared are at least internally consistent, then it just seems obviously better. I think I was almost instantly on board with it. The turning point for me about when I went all in was when I realized just how much better it makes the developer experience. IDEs like VS Code, I think PyCharm have their own type checker, but even if you use Vim, you can connect an LSP to that. So it's already tell you when you're doing something illegal without you having to run the code. It means that if you've got some symbol and you want to go to its definition, then with Vim key bindings, that's just GD. I think with VS Code, it's control click. But the fact that this just works so much better with type-ins. Like people talk about AI, like to me, the biggest gains in productivity have come from type-ins and LSPs. And Copilot has been mostly a waste of time compared to those. Just my personal experience.
But what's coming next? I'm curious. What should I be waiting for in the next couple of months? What's on the roadmap?
Main areas of focus at the moment are strengthening what we've done already, reducing overhead, and most importantly, getting order-defined functions supported for lazy engines. In the lazy API, we're not assuming anything to do with row order. So for anything order-dependent, such as a rolling mean, then this needs to be evaluated within a .over context in which you explicitly specify which column you want your observations to be ordered by. That's taken some huge refactors, but it's pretty close to working, so I'm pretty excited about that. And it won't be long until we're able to publish a stable.v2. And then I hope that this stable.v2 can be pretty much the definitive API for a long time. I hope that we don't have to do a stable.v3 anytime soon.
Is there a place where people can see your roadmap? So how do you communicate your roadmap with others?
There's the discussions feature on GitHub. I think I've pinned a couple of discussions. One is about the priorities for 2025. Another is about the road to stable.v2. People can take a look at those. We also tag some issues. If anyone's interested in contributing, sometimes I just stick a high priority label on an issue, which really is just meant to signal, if you submit a pull request for this, then I'll review it as quickly as possible. If anyone's interested in contributing, those are good ones to look out for.
So if people would like to reach out to you, what is the right way for people to reach out to you?
Yeah, there is the Narwhals Discord. I'm on LinkedIn as well. There is the GitHub. Yeah, I think there's a few ways that you can contact me if you want to speak to me about anything.
That's it for today's episode. I hope you enjoyed the conversation and found it valuable. If you did, please consider sharing this episode with your friends and family or anyone who might benefit from it. Also, I'd love to hear your thoughts, so take a moment to leave a review and let me know what you think. And if you haven't already, don't forget to give us a rating. It really helps us reach more people and bring you even more amazing content. Thanks for tuning in, and I'll catch you on the next episode.